Hello there and welcome to this course or this challenge on Pandas Day 9 challenge of 30. My name is Valentine and I'll be your instructor. In this challenge, we're going to be going through a set of concepts that we have gotten to practice in the past and also introduce a few more that we might have not covered in the past challenges. So let's get started. The first thing that we need to do is to visit the link in the description section of this video and click on the practice resource link, which should take you to this page that you see on your screen. Then click on sample practice resource, which you should find here. This resource has a few challenges, but if you want extensive challenges, you could always consider becoming an Afterwork member and you get challenges for each and every section in the practice notebook. So once you've gotten to the sample practice notebook, then the next thing that you need to do is to go to File, then save a copy in Drive to create a new, which will create a copy of this notebook in your Google Drive, and you can work on that copy and close down the original one. If you work on the original one, you won't be able to make to save those changes, and you won't have those changes that you'll have made accessible in the future. I'll be using the practice notebook. Once you have done that, the next thing that we need to do is to go to the prerequisite section and run the first code cell that's in the first section under prerequisite. So that will import pandas as PD. All right, we're good to go. The next thing that we need to do is now go through the first concept, which is just subsetting rows by row number. Sometimes we might want to, let me just go back a bit. We might want to select maybe some specific rows. Maybe if we have this data set, for instance, if we have this data set that you see here, this data set contains just some information about farms, what's actually planted in those farms, and how big it is, where it's located, etc. So if we wanted to maybe to select maybe the first 5 records, we could use the ilog method to do that. Like in our case here, we use the ilog method, we apply it to our original data frame, and then we specify inside the square brackets the rows that we want. Say this is the first 5, and then we display the records, the rows as shown here. So we could decide, let's even just run this. You should see that we have 5 records, but we can also decide to even have a range. So we might want maybe to specify a range from index 1 to 5. What essentially will happen is that we'll get the first of all the record that has index 1, which is the second record, and then it would be to index 5, so the one that has not index 5, the one that's before index 5. So that's sometimes when we specify 5 here, when we're working with a range, we usually get the last item before what we have specified here. That's what we have here. So 1 to 5. But if you wanted maybe to select specific records, we could do, maybe we put square brackets, another set of square brackets, and then we say, let's say index 2. Index 2 will be this particular record that we have here. All right, pause the video and then work on the challenge. In other cases, we can decide to create columns using what is called the assign function. So assuming that we have this data set and we wanted to create a new column out of existing columns, then we can apply the assign function to the data frame that we are working with. Then inside it, we specify, or we have like an expression. So we have the name of the new column, which is total profit, equal to the value of the one of the existing columns times, say, the other value of another column. So here we could have as complex as the expression that we want, and the outcome of that would be stored in total profit column. So essentially here we would end up creating a new total profit column on the far right. So this is what we're doing. Now on the far right you can see total profit. All right, pause the video and work on the challenge. In other cases, we might want to export the selected data, or the selected or transformed data to CSV format. So in our case here, we have this data set, and assuming that this is the data set that we have, assuming that we wanted to perform some data preprocessing tasks, such as just to select specific columns. Once we have done that, we can then have the preprocessed data exported maybe to a CSV file. So how we are able to export to CSV file is, as shown here. So we have selected the data. So this is the data that we've selected, which has fewer columns. And we apply the to_CSV function to that selected data. And in that function, we specify the CSV file name, and also we set index to false to just mean that we don't want to include an index column in the dataset, in the CSV dataset. So if I click on the far left, over here, if I run this code that you see here, I should be able to see that there will be a CSV file that will be exported there. So if I run this, you should be able to see that here. If I refresh this, you should see now this dataset, which I can download by clicking there. So yeah, pause the video and then work on the challenge. So aside from just being able to export the CSV, the data that we've transformed to a CSV file, we can also export it to Excel. So in our case, assuming that we have this data set, exported data to Excel. So this is the data. Assuming we wanted to export it to Excel, what we can do is we can decide to use the to Excel instead of using to CSV function. We can use to Excel function, and the same information remains the same, the name of the file, but we need to ensure that it has an XLSX format, and we also set the index to false. So if I run this, I should be able to see this new file over there. Then I run this and I should be able to see that. Pause the video and then work on the challenge. This is a concept that we got to learn in the previous challenge. Assuming that we wanted to create a summary table out of a bigger table, so basically a pivot table, but we wanted to use our own custom function. Instead of using the aggregate functions that we know, such as average, minimum, maximum, maybe we might have our own set of operations that we would want to apply to the group data that we have. So how do we create a summary table with our own custom function? So we would first of all define a function. So let me first of all show you. So let's load this data set. So assuming that we wanted to create a summary table to have crop type and also total profit, but total profit would be calculated based on maybe some custom function. So we need to define our custom function, and inside it we would perform operations and return the value. So in our case, we are just doing this sum of the profit that we have for a particular group. So once we do that, we can now create our summary table by using the group by function and use the crop type categorical variable to create the summary table. So on the left hand side, we'll have crop type, then on the right hand side we'll have the total profit. So we just use the apply function, and inside it we pass as an argument the custom function that we had. And so that would be it. This just reset index just ensures that we have a data frame format as the output. Here we're just setting the column names of our summary table, because essentially we don't get a column name for total profit column. But here, once you load this, we should be able to see now the crop type and also the total profit for that. Pause the video and then work on the challenge. In some cases, we might want to split columns based on certain conditions. Maybe we had a column called yield per acre. So in our case here, we have this data set which has yield per acre, and we might want to have split this column into maybe two new columns. One column has high yield and another one low yield. And how do we do that? We can use the lock method to define the expression that we want, as well as the column that we want to apply the expression to. So if in our case over here, so if I run this, you should be able to see that for the new columns, we should have values that tell us whether that particular record has a higher yield or low yield. So you should have yes or no, true or false values for such. Let's load that. Actually, I made a mistake, not true or false. So for the new columns that we are going to create, what we are going to be doing is that we are actually creating, so you're actually getting values for whether if that particular column has, let's say, high yield, we are having the value of high yield in that particular column. Or if it has low yield, we have that low yield column. For the NANs that you see, I think we could have done this a bit better, like enhanced it, so that instead of what we have here, we have true or false values instead. So, but yeah, but that should give us an idea of how we can create a new column and be able to work with from existing, splitting columns from existing data. Right, pause the video and then work on the challenge. In some cases, we might want to extract data components. So assuming that we have maybe a data set that looks like this, it has maybe, you can see planting date, harvest dates. Assuming that we wanted to extract maybe certain components like year, month, day. So we might want to decide to, let's say, we could decide to extract, in our case here, maybe the year, maybe the month. So if in our case, you might want to extract maybe 2021 month for March 10, that number. If we wanted to have a new column with that number, then we can be able to do that using now the approach that we have here. First of all, we convert the respective columns that we want to convert. So these are planting date as well as harvest date, which are here. And then we extract, once we've converted and we want to work with these ones, we would extract the year, month, and day components as shown. So we apply the dt.year, dt.month, dt.day. And then we can also do the same thing for harvest date, etc. and preview it as shown here. All right, pause the video and then work on the challenge. In some cases, we can decide to, this is a concept that we've worked on in the past, just creating a summary table. This is just a quick refresher of this concept. So we might want to create a summary table or pivot table from this particular data frame. So assuming that we wanted to create maybe a summary table that has region and then the sum of yield on the right hand side. How we do that is we use a group by function. Then we specify the column that we want on the left hand side of the pivot table, that's region. Then on the right hand side we want yield and we want the sum of yield, and we apply just reset index to ensure that we have a pandas data frame as an output. And then we display the aggregated data. So this is what we have, summary table out of that. Pause the video and then work on the challenge. Okay. All right. We can also aggregate. We can, instead of just having one function over here, we can have multiple functions to just be able to perform whatever tasks that we have. For example, if we have this, this particular column over here, not column data frame, assuming we wanted to have a smaller table with just maybe aggregate maybe functions of, maybe for total acres we might want to have sum, mean, and standard deviation. For total production, sum, mean, and we might want to have maybe a table that has columns called total acres, total production, and revenue, and then the respective sum, mean, and standard deviation values. So how we can be able to do that is using the aggregate function. So we apply the aggregate function to the data frame that we are working with, and we specify the value that we give the aggregate function as a dictionary where there are key value pairs. So this is a key, this is a value, key, value, etc. Pause the video and then work on the challenge. Lastly, in some cases, in some cases where we might need to filter maybe for data, but data that has specific data types, like for example, integers and floats, which is numerical data, we can we can use this approach that we're going to be learning in this section. So this is assuming this is our data set, and the data types are as shown. So the data types for crop type, we have object, which is just textual data, represented in Pandas. It's usually in an object form. Integers, floats, we have them over here. Assuming that we wanted to extract or select these records without using the other method for lists where we specify, let's say df, then square brackets, then another list inside, and specifying the columns themselves, we can decide to use the select data types function, and then inside it we just specify the specific data types that we want to work with. And that's generally what we would need to do. So here we've gotten the numerical columns, and we've saved them in numerical columns, and we've previewed them as shown. Right, pause the video and then work on the challenge. Right, so that's it with regards to this this particular challenge on day 9 of the Pandas series, or the Pandas challenge. If you did find value in this challenge, be sure to give this video a thumbs up. And if you'd want to be informed, be sure to be informed when we post future courses. Be sure to subscribe. So see you again the next day on day 10 of this Pandas challenge. Bye-bye.